Alright guys, in this lesson we are going to solve a quadratic by taking the square root. So we're moving into our solving of quadratics, which remember that's where we're talking about the x-intercepts. So we actually have 5 methods that we can use to solve a quadratic. We can solve it by graphing and looking for those x-intercepts. We're going to talk about factoring. We're going to talk about square root today. We can do the quadratic formula and completing the square. But today we're going to focus on that square root method. By the end of this lesson, you should be able to take these 6 problems and solve for the x's. Alright, so I just want you to take a minute and think about what solution or solutions would exist for this problem. So I'm going to guess that most of you were able to come up with the x as 10 because 10 squared is 100, but negative 10 times negative 10 is also 100. So we have to remember that whenever we square root a variable, we have to think about that this has 2 possible answers. It can be positive or it can be negative. That's really important. So that's the square root property, that when I square root, I always have, so I have x squared equals c, then I have a positive solution, which is the square root of c, and I have a negative solution, which is the negative square root of c. You might also see it written like this. So for the previous example, it might look like that. And what that just means is x equals positive or negative 10. So it's just combining it in a faster method to write. Alright, so the biggest thing that you have to keep in mind, the only time we use the square root method is when there is no bx term. There's no linear term. So I just have the quadratic term and the linear term, or the constant term at the end. So the first question we always ask ourselves is there a bx term? Because if the answer is yes, then I can't use the square root method. Then is the x squared term isolated? How do I undo squaring? And have I included all solutions? So that's reminding you to have the positive and the negative version. And then we're going to talk about simplifying the radical, which is review of Algebra 1, but it may be a little rusty for you. So to help us with simplifying the radical, what I want you to do is on your paper, I want you to write your perfect squares. So we've talked a lot about these. These are super important to memorize, be familiar with, know. And I would go up to 144. You're probably going to live mostly in these lower ones, but that's going to be really important that you have those numbers easily available and recognizable for you. Alright, so in this first example, the first question I'm asking myself is there a bx term? Which there isn't. I just have my quadratic term and my constant. There's no bx term, so I can use the square root method. Is the x squared term isolated? So when I look at this, the squared is isolated. Everything else is on the other side. So then how do I undo squaring? I square root. And what I do to one side, I have to do to the other. So square rooting and squaring cancel, and I have x equals. Now, remember, I can talk about a positive number and a negative number that will get me there. So I can write it as plus or minus the square root of 72. Or if you wanted to, you could write it as x equals the negative square root of 72 and the square root of 72. So you could write it that way. It doesn't matter. But then my last question is, can I simplify the radical? So obviously the square root of 72 gives me a decimal. It's not a perfect square. But I need to see if I can simplify that. So just like we simplify a fraction, just like we take 4 over 8 and reduce it to 1/2, we're going to simplify 72. So when I think about those perfect squares, I want to start up here and work my way backwards. And I'm literally going to see which one of these can go evenly into 72. So I could turn 72 into a perfect square times another number. So when I think about 72, obviously 81 can't go into it evenly. 64 does not go into it evenly. 49 doesn't. And if you notice, the only perfect squares that are going to go into 72 are going to be evens. So I can go ahead and rule out the odds. So then I'm going to try 36. And when I do 36, 72 is actually 36 times 2. And I chose 36 because it's a perfect square. There are other numbers that go into 72, but I want those perfect squares. So I'm actually going to rewrite 72 as the square root of 36 times the square root of 2. Because if I multiply 36 times 2, I get 72. So I've just written it in a factored form. Well, the square root of 36 is 6. So this is actually plus or minus 6 root 2. And that is my solution. So if you go back and check with your calculator, if you do the square root of 72 and you do 6 times the square root of 2, you should end up with the same answer because those mean the same thing. Just like 4 over 8 means 1/2, the square root of 72 and 6 root 2 are the same value. So when I think about what do these solutions mean in terms of the graph, we said there's multiple ways to solve a quadratic. We can graph it or we can square root it. So what it means is on the graph, these are the two places where that quadratic crosses the x-axis because solutions are the roots. So this is crossing at positive root 72 or 6 root 2, and it's crossing at negative. So remember that a quadratic usually has two solutions. And so we have to think about that plus and minus. All right, so I'd like you to take example 2 and see how far you can get with this problem. So hopefully you were able to at least get the first step done where I square root both sides, and then recognizing that I have a positive and negative version of the square root of 200 because it's a quadratic, so it's probably going to have two solutions like we see down here. And then simplifying the radical, when I think about 200, I can rewrite 200 as 100 times 2. And the reason that I chose 100 times 2 and not 50 times 4 is because 100 is the largest perfect square that can go into 200. And so the square root of 100 is 10, so my solution is positive and negative 10 root 2. So what does that mean on a graph? That means that at 10 root 2, which 10 root 2 is 14.14. So this graph is essentially crossing at 14.14 and negative 14.14. That's what that means on a graph. So I can always double check my answer by graphing it. All right, so example 3. Is there a bx term? No. I still have my quadratic term and my constant term. Is the x squared term isolated? So when I look at this, I have x squared minus 8. So it's not isolated. So I'm going to add 8. So I have x squared equals 8. All right, how do I undo squaring? Well, I'm going to square root both sides. So x equals, and I can't forget I have a positive and negative square root of 8. But then I need to think, can I simplify the radical? So when I think about 8, it's a pretty small number, but the square root of 4, which is a perfect square, can go into it. So 8 is really the square root of 4 times the square root of 2, because 4 times 2 is 8. And so the square root of 4 is 2. So my solution is really plus or minus 2 root 2. All right, go ahead and try example 4 on your own. All right, go ahead and check your answer and identify any questions that you might have about example 4 so you can talk about it in your CSG. All right, example 5. So again, I'm going to go through that same process. I'm going to isolate my square roots. So x squared equals negative 10. And then I'm going to square root both sides. So I have x equals positive or negative square root of negative 10. Now in your head, alarms should be going off because I cannot square root a negative number right now. We'll learn about imaginary numbers in a little bit. So this is going to be no real solution because I cannot have a negative under the square root sign. So when I think about what this looks like on a graph, it's going to be the quadratic that has no roots. It doesn't cross the x-axis. So that's what's happening. If I ever go to isolate my x squared and the number is negative that I'm going to square root, then I will write no real solution. So go ahead and try number 6 on your own. Hopefully you were able to recognize it's also going to be no real solution, because when I take negative 144 and divide it by 2, I end up with negative 72, and there is no number times itself that will give me negative 72, so that's going to be a no real solution problem. Now, some people, if I looked at this and it were negative 2 in front of that, negative 144 divided by negative 2 gives me a positive, so that I can solve. So just because it equals a negative number, I have to see what's going on over here before I determine that it's no real solution. All right, so I'd like you to try example 10 on your own, and that is a problem you're going to discuss with your CSG in class. So let's look at example 8. So it looks like a little bit different, but we're going to go through that same process. And I want to point out that in this case, this right here is my quadratic term. That is the value that's being squared. So whatever value is being squared, that's my quadratic term. So like in this one, that's my quadratic term. So we're going to use that definition of this being the quadratic term. And we're going to ask, is there a bx term? There's not, because I have a quadratic term, and then I have my constant over here. Is the x squared term isolated? Well, it's not, because I have an 8. So what's happening between the quadratic and the 8 is being multiplied. So to undo it, I'm going to divide. So on this side, I have b minus 7 squared equals 18. All right, so how do I undo squaring? Well, I square root. So I'm going to square root the whole thing. So those will cancel, and I have b minus 7 equals, and I'm going to have positive root 18 and negative root 18. Now you can put them together, and I'll show you what that looks like, but when you have to do more solving after you square root, it's just easier to separate them first. All right, so right now I'm going to go ahead and simplify my radical just to make my life easier, because I recognize that the square root of 18 is really the square root of 9 times the square root of 2. And the square root of 9 is 3. So I'm actually going to rewrite this as b minus 7 equals 3 root 2, and b minus 7 equals negative 3 root 2. All right, so to solve for b, I simply have to add 7 and add 7. So my answer is actually b equals, and if you notice, I have a positive version of this and I have a negative version, so I can write it as plus or minus 3 root 2 plus 7. And those are my two solutions to that square root problem. All right, I'd like you to try example 9 on your own. All right, so hopefully you didn't get thrown off by the 0, but when I add 6, negative 36 and positive 36 are 0, and then I divide by 6, 0 divided by 6 is 0. Now, some of you may wanted to say no solution, and remember, I can take 0 and divide it by anything. I just can't take a number and divide it by 0. And so then when I square root 0, the square root of 0 is 0, and we always want to remember there's two solutions. Well, positive 0 and negative 0 don't exist. It's just 0. So what that means is that, excuse me, when my squared term equals 0, that means we're just talking about a quadratic that's on the x-axis. So remember we talked about quadratics can have no real solutions. So if it's above the x-axis and opens up, it can have two solutions, so where it's crossing the x-axis twice, or it can have one solution where it's just sitting on the x-axis. So that's what's happening in example 9. So go ahead and try example 10 on your own. And hopefully you see that as well. This is where x equals 0. All right, I'd like you to do examples 11 and 12 on your own. Write them down, solve them out, and you're going to talk about them in your CSG groups next time we have class. I'd also like you to do example 13 and 14 on your own. All right, that's our lesson on solving quadratics by square root. So please have an interaction in your notes. So what do you understand? What questions do you have? Which ones did you have a problem with? You're going to compare your answers and discuss in your CSG on in our next class.